Good morning, this is your Stat Sensei, Mr. Spensei, and this is from the notes. This is a shopping mall, and this is a warm-up on one sample proportions, and we're going to look at both a hypothesis test and a confidence interval. So a particular shopping mall has 7,500 visitors. That right there sounds like a population to me. During a typical week, 60% of the visitors spend over $125 when they visit the mall. This sounds like this is my claim. This sounds like this is P naught. So we're going to say P naught is 60% or 0.60. The mall was recently remodeled, and the owners of the mall are trying to determine the percentage of visitors spending at least $125, and they want to know if it has increased. So we have an HA. Our alternative hypothesis is, has it increased? A SRS, a simple random sample of 550. So we know we have a simple random sample that takes care of our condition. And we have a sample size of 550. Leaving the mall showed that 64% had spent over 125,000. Well, this came from the sample. So this 64% is our P hat. All right. Add alpha equals 5%. So we know our alpha level is 0.05. Has a proportion of shoppers spending more than 125,000? Has it increased? And we've already have that. We've already listed that as a greater than. Obviously, this is our formula. So our sample proportion minus our population proportion. And notice, please make note, this is population proportion down here. All right. And then, of course, we have our sample size. So when we go to list our data, the very first thing it asks for is X. Well, we don't have that, and we'll talk about it in a moment. They gave us P hat, which is 64%. We noted that. We also noted our sample size of 550, and we know the population claim was 60%. So how do we get X? All right, because we have to have X for the calculator. This is what we'll plug into the formula. That's all nice. But for the calculator purposes, we need X. So to get X, we're going to set up a proportion because P hat, or the 64%, equals X over the sample size. So X over 550. When we multiply 64 times 550, we find out that X is 352. So there's our sample size, and we had to actually solve for that, and that's why that's in that purplish color. All right, what are we about to do? We're about to run a one proportion Z-test. So I'm going to go ahead and say, hey, we need to start looking at what this looks like on the graph. Excuse me. And on a graph, if we're talking about drawing for a hypothesis test, we're always going to be centered on the population proportion. So we're centered on the population proportion. And our population proportion happens to be 0.60. So we're centered on that. We know our P hat above there, and we also know that our alternative is greater than, so we highlighted the greater than, and that's what we have there. Okay, so we go ahead and start plugging all our information in. And as I said earlier, we didn't even need the 352 to plug into the formula. However, it's going to be really important on the calculator. And so here we go. All right, on the calculator, stat, test, drop down to one proportion Z-test, which is number 5. And it asks for PO, which is basically the 0.6, or if you wanted to do 60 divided by 100, so that gives you the 0.6. Our X, which we had to calculate, was 352. Our N was 550. And we said that, hey, we're shading up, so this is a greater than. And we ended up getting a z-score of 1.914 and a p-value of 0.0277. Well, our alpha is 0.05. So with that being the case, our decision is going to be to reject a null, but we'll get back to that in a moment. So here's our claim. Our claim is P equals 60%, and we said that it was going to be greater than. If you'll notice, we have a greater than highlighted there, and we have a greater than highlighted there. We're being consistent. And there's our values from our calculator. Probability Z is greater than 1.9148. Once again, being consistent with that greater than. We end up with a p-value of 0.0277. And our 0.0277 is less than the alpha of 0.05. Make sure you always make them the same length because you can easily see 277 is less than 500. So our decision is to reject the null. All right, continuing on, creating the confidence interval. All right, so we're going to create a confidence interval for that. And basically our confidence interval formula is this. But notice instead of working with the population proportion down here, because previously on the Z, our standard error was based on the population proportion. This is based on the sample proportion. Why? Because we don't know what the population is. We're estimating. So P hat sample proportion plus or minus Z star P hat 1 minus P divided by the square root of N. All right, to calculate Z star, because we already have P hat from up above, we said P hat was, 64%. But to plug in, we already have our N of 550. So the one thing we're missing from this is Z star. And to do that, we're going to go second vars, inverse norm, parenthesis 1 minus 0.98, close parenthesis, divided by 2, mean of 0, standard deviation of 1. And we end up getting a Z star of 2.3263. Oh, and on the calculator, it's negative, but we're positive people, so we're going to keep it simple and always leave it as a positive. Well, at this point, we can go ahead and plug in because right here we have Z star, and we plug that in there. There's our sample proportion. This is our P hat. This is also P hat and P hat. And this right here is our N. Well, when we go to actually run this, oh, and by the way, as you already know, this is a one proportion Z interval, which is what it'll say on the calculator. But when we actually go to draw this, the hypothesis test was centered on the population, whereas the sample will be, the confidence interval will be centered on P hat. All right, so we need to be centered on P hat. This area right here that we're looking for is 98%. We know that we're going to have a lower bound and an upper bound and a P hat of 0.64. So let's go ahead and run this test. So we're going to go stat test. And we're going to have to scroll way down, all right, to letter A, which is a one proportion Z interval. Press enter. And our X from above was 352. Our sample size is 550, 64%, and we have a confidence level of 0.98 or 98 divided by 100. And that ends up being our lower bound. So somewhere between 59% and 68%. All right. So that's our warm up for today. I hope that helped a lot. And since we just looked at this yesterday for the first time. All right. Look forward to seeing you on the next one. And by the way, there we go. Make sure that shows up. And look forward to seeing you on the next one. Thank you.